Westinghouse-designed AP1000 reactors approved for China. Date: August 29, 2024. Overview. On August 29, 2024, the State Council of China granted approval for the construction of 4 AP1000 nuclear reactors designed by Westinghouse Electric Company. This significant decision marks a continued commitment by China to expand its nuclear energy capabilities and reflects the country's ongoing investment in clean and efficient energy sources. The approval was jointly secured by the State Power Investment Corporation (SPIC) and the China General Nuclear Power Corporation (CGN) and will enhance the number of operational and approved AP1000 reactors in China to 16. Project details. The approved reactors will be constructed in 2 locations. Bailong Nuclear Power Project in Guangxi Province, where 2 of the reactors will be built. This project is planned to include a total of 6 AP1000 reactors, 2 of which can now commence construction with preparatory groundwork. Lufeng Nuclear Power Plant in Guangdong Province, where the other 2 reactors are set to be built. Construction activities at this site are already underway, with preparations for the first concrete day FCD of the Nuclear Island Foundation taking place. Significance of AP1000 technology. The AP1000 reactor design is notable for its advanced safety features, including fully passive safety systems, modular construction design, and a compact footprint per megawatt of electric output. This technology has been recognized globally for its operational efficiency, with both the reactors in Georgia, USA, and the 8 under construction in China setting high standards for performance and reliability. The AP1000 has garnered interest from various countries including Poland, Ukraine, and Bulgaria, further indicating its growing acceptance in the global nuclear market. Patrick Fregman, the CEO of Westinghouse, emphasized the AP1000's reputation as a long-term investment option for utilities, fostering safe, clean, and reliable baseload electricity. He noted that with the new approvals, a total of 18 AP1000 reactors are expected to be operational globally by the end of the decade. China's nuclear expansion plans. China's ambitious nuclear energy program has received substantial governmental support, positioning the country as a leader in nuclear energy expansion. Currently, China operates 56 nuclear reactors and has 27 more under construction. The government aims to build an additional 6 to 8 reactors each year, with projections indicating that China may surpass the United States in nuclear electricity generation capacity by 2030. Timeline of events. August 29, 2024, announcement of the approval for 4 new AP1000 reactors by the State Council of China. 2024, preparation for construction begins at both the Bailong and Lufeng sites. 2030, projections suggest China will exceed the US in nuclear power generation capacity. Conclusion. The approval of the AP1000 reactors in China reflects a significant step in the country's energy strategy, emphasizing the role of nuclear power in achieving energy security and sustainability goals. The continued deployment of this advanced reactor technology not only enhances China's energy infrastructure but also contributes to global efforts in promoting clean energy alternatives. As the world increasingly turns to sustainable energy sources, China's investment in nuclear energy positions it at the forefront of the global energy transition. The approval of 4 Westinghouse-designed AP1000 reactors for construction in China is a significant development in the country's nuclear energy landscape. This decision, made by the State Council of China on August 29, 2024, supports a broader strategy aimed at expanding nuclear energy capacity amid global concerns about energy security and climate change. Counterintuitive information. 1. Rapid expansion despite global hesitance. While many countries are retreating from nuclear power or are hesitant to expand their nuclear fleets due to safety concerns, China is aggressively pursuing nuclear energy as a primary power source. This contrasts with global trends where nuclear energy programs have been slowed or halted, particularly in the aftermath of incidents like Fukushima. 2. China's nuclear policy as a climate strategy. The decision to build more nuclear reactors may seem counterintuitive given the global push for renewable energy sources such as solar and wind. However, China views nuclear energy as a necessary component of its strategy to reduce carbon emissions and combat climate change, aligning with its commitments under international climate agreements. 3. AP1000's unique safety features. The AP1000 reactor is noted for its fully passive safety systems, which is a selling point for its adoption. It may seem that older technologies would be preferred in a conservative approach to nuclear energy expansion. However, the innovative safety features of the AP1000, which utilize natural forces like gravity and convection to operate safely, make it appealing to countries like China that are looking to modernize their energy infrastructure while ensuring safety. 4. China's government support versus market dynamics. While in many countries the development and expansion of nuclear energy face significant public opposition and regulatory hurdles, in China the government plays a crucial role in supporting and funding nuclear projects. This top-down approach can lead to rapid development that contrasts sharply with the slower, more deliberative processes seen in democracies where public opinion heavily influences energy policy. 5. Investment in nuclear over renewables. It may seem illogical that a country investing heavily in nuclear power would also be leading in renewable energy development. However, China aims to diversify its energy portfolio and believes that nuclear energy will provide a stable baseload power supply that complements intermittent renewable sources like wind and solar. This dual approach challenges the notion that countries must choose between nuclear and renewable energy. 6. Global implications of China's nuclear growth. The approval of these reactors is not just significant for China but has implications for global energy markets and geopolitical dynamics. As China's nuclear capacity expands, it may influence global nuclear energy policies, potentially leading other nations to reconsider their own nuclear strategies despite domestic opposition or concerns over safety. 7. AP1000's international adoption. The AP1000 technology is being considered in various countries, including those in Eastern Europe and beyond, despite the fact that some of these nations have historically been skeptical about nuclear power. This suggests a shift in perception about the viability and safety of nuclear energy, driven by technological advancements and the urgent need for reliable energy sources. 8. Economic impact and energy security. The construction of new nuclear reactors may seem economically burdensome given the high initial investment required. However, the long-term economic benefits in terms of energy security, job creation in high-tech fields, and the stabilization of energy prices can outweigh these initial costs, making it a strategic economic move for China amidst fluctuating global energy markets. 9. Public perception of nuclear safety. In China, public perception of nuclear safety may contrast sharply with views in Western countries where nuclear energy is often met with skepticism. This difference in perception allows for a more straightforward approval and implementation process for nuclear projects in China. 10. China's role in global nuclear innovation. While the West, particularly the US, has historically been seen as a leader in nuclear technology, China's rapid advancements in nuclear energy technology and construction capabilities position it as a new leader in the global nuclear sector. This shift could redefine global energy leadership and influence how nuclear technology is shared and implemented worldwide. In summary, the approval of these AP1000 reactors reflects a complex interplay of factors that challenge conventional wisdom about nuclear energy expansion. China's approach to nuclear energy is not merely about increasing capacity, it is also a calculated response to global energy demand, safety considerations, and climate goals which may redefine the future of energy production and consumption on a global scale. The recent approval by China's State Council for the construction of 4 AP1000 reactors designed by Westinghouse Electric Company is a pivotal event in the global energy landscape that warrants close examination. While many reports focus on the immediate implications for China's nuclear power capabilities, several significant aspects are often overlooked that could have far-reaching consequences. 1. Passive safety systems and technological leadership. The AP1000 reactor is notable for its fully passive safety systems, a hallmark of its design that distinguishes it from many other reactor types. This technology allows the reactor to maintain safe operations without the need for active mechanical systems in the event of an emergency. This feature is crucial for enhancing public confidence in nuclear energy, a sector still recovering from historical accidents. The significance lies in the global implications of adopting more advanced safety technologies. Countries looking to expand or introduce nuclear capabilities may view China's commitment to the AP1000 as a model. This could lead to increased international interest in passive safety systems, potentially reshaping the global nuclear energy market and affecting regulatory standards worldwide. 2. Modular construction design. The modular design of the AP1000 reactor allows for more efficient construction processes and potentially lower costs. This approach not only accelerates the timeline for bringing reactors online but also reduces the complexities typically associated with nuclear construction. This aspect is particularly significant because it addresses one of the main criticisms of nuclear energy: the lengthy and often over-budget construction timelines. If China successfully demonstrates the benefits of modular construction, it could set a precedent that encourages other nations to adopt similar technologies, thereby revitalizing global interest in nuclear energy. 3. Geopolitical implications. China's aggressive expansion of its nuclear capabilities, supported by the government, positions it as a leader in nuclear technology. By increasing its nuclear power output, China not only seeks energy security but also enhances its standing in international energy politics. This shift could lead to geopolitical ramifications as China becomes less reliant on fossil fuel imports, thus altering energy dynamics in regions that are traditionally energy suppliers. Moreover, as China engages in nuclear projects in other countries such as Poland and Ukraine, it may influence energy policies and regulatory frameworks in those nations, extending its strategic reach. 4. Economic and environmental considerations. The approval for the AP1000 reactors aligns with China's goals to reduce carbon emissions and transition to cleaner energy sources. Nuclear energy offers a significant opportunity to achieve these targets, particularly as China faces challenges associated with air pollution from coal-fired power plants. The economic implications are substantial as well. With an increase in nuclear power generation, China could potentially reduce its dependence on imported fossil fuels, stabilizing energy prices and enhancing domestic energy security. This move is not just an environmental strategy but a calculated economic shift with the potential to create jobs in construction and maintenance of nuclear facilities. 5. Future of nuclear power. As China aims to construct 6 to 8 new reactors annually, this ambitious goal signals a potential resurgence in nuclear power globally. The AP1000 reactors could serve as a benchmark for future designs and innovations. However, the broader narrative often overlooks the importance of public perception and regulatory frameworks that will evolve alongside technological advancements. The success of these reactors in China could lead to a re-evaluation of nuclear energy in public discourse, potentially overcoming the stigma associated with nuclear power and fostering a more favorable environment for new projects worldwide. In conclusion, while the immediate benefits of the approved AP1000 reactors in China are evident, the overlooked aspects ranging from technological advancements in safety and construction, geopolitical shifts, and economic implications underscore the broader significance of this development. As China leads the charge in nuclear expansion, the global energy landscape may undergo transformative changes that could redefine energy security, environmental strategies, and international relations in the coming decades. The approval of 4 Westinghouse-designed AP1000 reactors in China represents a significant milestone in the country's nuclear energy strategy and has several implications for the global nuclear landscape. Here are the 4 most valuable points to analyze and discuss in depth. 1. Technological advancements and safety features of AP1000 reactors. The AP1000 reactor design is notable for its advanced safety systems, which are entirely passive. This means that in the event of a malfunction, the reactor can cool itself without human intervention or external power, significantly enhancing safety. The modular construction design also allows for quicker and more efficient building processes, reducing labor costs and construction time. This technology has been recognized for its operational efficiency and reliability, making it an attractive option for utilities globally. 2. China's nuclear expansion strategy and global leadership. China's approval of these reactors underscores its ambitious nuclear expansion strategy, aiming to increase its nuclear generation capacity significantly. With plans to build 6 to 8 new reactors annually, China is poised to surpass the United States in nuclear electricity generation by 2030. This rapid expansion reflects the Chinese government's commitment to clean energy and reducing carbon emissions, positioning China as a leader in the global nuclear energy market. The approval also mirrors the country's ongoing efforts to modernize its energy infrastructure and reduce reliance on fossil fuels. 3. International collaboration and influence of Westinghouse technology. The partnership between Westinghouse Electric Company and Chinese state-owned enterprises like SPIC and CGN illustrates the growing trend of international collaboration in nuclear technology. The AP1000 reactors are not only being deployed in China but are also being considered in various countries including Poland, Ukraine, and Bulgaria. This increasing adoption of the AP1000 technology globally can influence international nuclear standards and practices, potentially leading to more uniformity in safety protocols and operational procedures across different regions. 4. Economic and environmental implications. The construction of these reactors is expected to provide a reliable source of clean energy, contributing to China's energy security and sustainability goals. Economically, the investment in nuclear power can generate jobs and stimulate local economies, particularly in the regions where these plants are built. Additionally, as China aims to reduce its carbon footprint, the expansion of nuclear power is crucial in achieving its climate goals. The increase in nuclear capacity is likely to lead to a decrease in coal reliance, thus improving air quality and reducing greenhouse gas emissions. Conclusion. The approval of the 4 AP1000 reactors in China is a pivotal development in both national and global contexts. It highlights advancements in nuclear technology, reflects China's strategic energy goals, showcases international cooperation in the nuclear sector, and underscores the economic and environmental benefits of nuclear energy. As the world navigates the complexities of energy production and climate change, the outcomes of this expansion will be closely watched by policymakers, industry stakeholders, and environmental advocates alike. 1. The construction of the 3 Mile Island Plant 1974 to 1978. The 3 Mile Island Nuclear Power Plant in Pennsylvania, USA was one of the first commercial nuclear power plants in the country. Designed by the General Public Utilities Corporation and Westinghouse, it began operations in 1978. However, the plant became infamous for a partial meltdown that occurred in 1979, which raised significant safety concerns about nuclear energy. The incident led to changes in regulatory oversight and public perception of nuclear power. Much like how the approval of new reactors in China reflects advancements in technology and safety measures. 2. The approval and construction of the Olkiluoto 3 reactor in Finland 2005 to 2022. The Olkiluoto 3 nuclear reactor in Finland is notable for being one of the first European pressurized reactors EPR constructed. Its approval by the Finnish government in 2005 marked a significant step in nuclear energy development in Europe. The project faced numerous delays and cost overruns, mirroring challenges faced in large-scale nuclear projects globally. The Olkiluoto 3 reactor's eventual completion and its advanced safety systems highlight the ongoing evolution and acceptance of nuclear technology similar to the AP1000 reactors being approved in China. 3. The Fukushima Daiichi nuclear disaster 2011. the Fukushima disaster in Japan had a profound impact on nuclear energy policies worldwide. Following the earthquake and tsunami that caused meltdowns in 3 reactors, there was a global re-evaluation of nuclear safety standards and technologies. This led many countries to reconsider their nuclear programs and invest in advanced safety features. The AP1000 reactors design, which includes fully passive safety systems, reflects the lessons learned from Fukushima and represents a shift towards safer nuclear technology paralleling China's recent approvals of such reactors. The future of nuclear energy, particularly through the adoption of Westinghouse-designed AP1000 reactors in China, presents a dynamic landscape of growth and innovation. The recent approval for the construction of 4 additional AP1000 reactors marks a pivotal moment in China's nuclear energy strategy, reflecting both the country's commitment to expanding its nuclear capabilities and the technological advancements embodied in the AP1000 design. Growth projections for China's nuclear energy sector. 1. Increased reactor construction, with the approval of the 4 new reactors. China is poised to significantly increase its nuclear capacity. The country is expected to construct 6 to 8 new reactors annually. By 2030, predictions suggest that China's nuclear power generation capacity could surpass that of the United States. This trajectory indicates a robust commitment to nuclear energy as a cornerstone of China's energy policy. 2. Total capacity expansion, by the end of the decade with the addition of the new reactors. It is anticipated that there will be 18 operational AP1000 reactors globally. This growth is indicative of a broader trend wherein countries are increasingly recognizing the reliability and safety of advanced nuclear technologies to meet energy demands and address climate change. Technological advancements and safety features. 1. AP1000 advantages. The AP1000 reactor stands out due to its fully passive safety systems and modular construction design. These features not only enhance safety but also reduce construction time and costs. The small footprint of the AP1000 makes it an attractive option for many countries seeking to develop or expand their nuclear energy capabilities without extensive land requirements. 2. Global adoption. The AP1000 technology is not just limited to China. It has been selected for nuclear projects in Poland, Ukraine, and Bulgaria, with considerations for additional sites in Central and Eastern Europe, the UK, India, and North America. This broad interest underscores the AP1000's reputation as a leading and proven technology in the global nuclear market. Environmental and economic impacts. 1. Reduction in carbon emissions. As nations grapple with climate change, the expansion of nuclear energy presents a viable path towards reducing carbon emissions. Nuclear power is a low-carbon energy source, and its increased adoption in China aligns with global efforts to transition towards cleaner energy. 2. Job creation and economic growth. The construction and operation of new nuclear facilities will generate significant employment opportunities, contributing to local economies. Moreover, the establishment of a reliable and sustainable energy infrastructure will bolster economic stability and growth. Challenges and considerations. 1. Public perception and safety concerns. Despite the advancements in nuclear technology, public perception remains a critical factor in the expansion of nuclear power. Past incidents have led to skepticism regarding nuclear safety. Ongoing education and transparency about the safety features of AP1000 reactors will be essential in gaining public trust. 2. Regulatory hurdles. As China continues to expand its nuclear footprint, navigating the regulatory landscape will be crucial. Ensuring compliance with both domestic and international safety standards will be vital for maintaining safety and securing future project approvals. Conclusion. The future of nuclear energy in China, particularly through the deployment of Westinghouse's AP1000 reactors, appears promising. The combination of government support, technological innovation, and a commitment to reducing carbon emissions positions China as a leader in the global nuclear energy landscape. as the nation moves towards its ambitious goals for 2030 and beyond. The success of these initiatives will likely serve as a model for other countries looking to harness the benefits of nuclear power in a sustainable and safe manner.